This is Sam with Nexus Workshop, and we are going through all the different input and output options. This video I kind of debated whether or not I was going to even make, because it's kind of not going to say a whole lot of definitive information. It's just kind of out there. But this is the input modules. So there are a number of input modules that are available right now. There's also a bunch more that I'm adding soon. Of the ones that are available now, I think the one that's going to be used the most by far is the RC522. That is your kind of off-the-shelf standard RFID reader. The standard little blue board that you get on Amazon. Those work pretty well. As you hook them up, they are SPI based, which means they're going to have a number of pins on them. So when you add your first one, it's going to add an SPI bus across the top. That bus is shared, and so it's going to give you a clock, a MOSI, and a MISO there. And those three pins are things that everything on the SPI bus will use those same pins. You're just going to take the pin, break it out to your devices. The other thing that's actually shared on them is going to be a reset pin, but it's going to show up on the module itself. The first one, you're going to define it, and then every other one after that, it'll be grayed out because it's just going to use that same first one. And then two more shared pins you're going to have are power and ground. This one is debatable. The RC522 is a 3.3 volt module, and you're not supposed to put 5 volt onto it. I have. It's fine. But your mileage may vary. Depends on which clone, which version you get, whether it's going to help, hurt, or do nothing. But theoretically, you should be powering them off of 3.3 volts. Either way, it's not going to mess with the board. So now we have 5 of our wires. We have our power, ground, reset. Oh, no, sorry, 6. Power, ground, reset, clock, MOSI, MISO. The last pin is our SDA, or our chip select. It's going to be labeled different things, either SDA or CS, but it is the pin that says, hey, I want to talk to you. And that's because SPI can only have one person talking at the same time. So you have those MOSI and those MISO lines. That is basically TXRX. It's who's talking and who's following. And then the chip select is going to choose who's allowed to talk at which point. The chip select is just a digital pin. The others all need to be, I guess reset doesn't have to be a pin on the board. Power and ground aren't actually using up a pin per se. But those three, MOSI, MISO, and clock, must be direct pins on your prop controller module. The chip select pin, the SDA, and the reset pin could be on a form of like an I2C expander or a digital expander. So that's going to matter because off the bat, you could only hook up, if you used every single pin on here, you could hook up 7 RC522s. I have so far tested it with 6, and it works well. Actually, you can see it blurred out behind me there, but that's my little board with 6 of them on there. And so that is working well on the board. 6 of them completely hooked up, which is a pretty big deal. Not many things out there can handle that. But that's going to use up all your pins, and so you're probably going to want like an I2C expander to give you more digital pins, and all those chip selects are going to move on to that. That's kind of what you need to do on the input side of those. So let's go and move to another one, which is I2C. That's another type of bus, and I just mentioned it there with that I2C digital expander. So there's a little expander module you can get that is I2C, which is a type of bus. It uses 2 pins, a data pin and a clock pin, and then it can give you things. So that's how like our color sensors we use work. That's how a lot of different digital sensors that we use work. It is a bus, so it's going to show up at the top of that input section for you, or the inputs and output section in the UI. Shows up there with definition of which those 2 pins are, and then like the other things, those are bus pins, so you're just going to take those and split them out. I2C cannot run a whole lot of distance, and it's not near as fast as SPI. Whether or not you see an issue with this, time will tell, but this is how you're going to connect a lot of your like little LCD modules and things like that. The big thing that you're going to use a lot, though, is that I2C expander, and that's going to use up 2 of your pins. They do need to be pins on your board, but then that's going to give you 16 digital-only pins. Those digital pins can be used as inputs. They can be your simple inputs, your buttons, things like that. They cannot be analog inputs. They don't have that ability, but they can be digital inputs, buttons, relays, buttons, switches, read switches, or digital outputs, relays. And they can also be your digital inputs for your chip selects on your RC522 modules. It's a lot of nomenclature, that was a lot of numbers. Other things that you have in your input modules are, there's some serial modules, there's some things like the DMX input and output, that's using UART, which is a form of serial. Other things, and you're going to see more things coming out from us constantly, but that's just in general saying that input modules typically need to be pins on your board. Sometimes use buses, which are shared pins that will get used over and over again, but can be freely defined into any of the pins available on the board. And that's input modules. Our next thing we're going to talk about, our last thing we're going to talk about in our little I/O stage here is pixels.